Dear participants, good afternoon. Uh, this session will have the topic of integration of AR, VR and 3D printing. And we will not have to wait for the resource person to join from outside. I am going to hold this session for you. And before that, give me a moment, please. Yeah, welcome back, everybody. Um, Since I'm your host for this entire program, I would have loved to welcome each of you physically had we had an offline session. But since this is an online session, we are lucky enough to have technology to our rescue, and we still have scope to connect. So I welcome you all to this session, and I hope you all will take away some knowledge or some information from it. So let me share my PPT with you. Dear participants, I hope it is now visible full screen. So the topic is integration of augmented reality and virtual reality and 3D printing. For the last 8 sessions, we have seen what augmented reality is, what virtual reality is, and in one of the sessions, we also saw what mixed reality is. So now we have a fair idea of what these technologies are: realities, virtual realities, and extended realities and realities as well. So this, for most part of the session, we concentrate on 3D printing, and then we'll go to how we can integrate AR, VR, and 3D printing. What actually is 3D printing? We call it printing, and the moment we say printing, the thing that comes to our mind is printing on paper. And when we are talking about 3D printing, it's three-dimensional printing That is why it is also called as desktop manufacturing or rapid manufacturing or on-demand manufacturing. We print a complete three-dimensional model which is tangible, we can hold in our hand and sometimes make use of in a lot of fields. We'll see that in the coming slides. So 3D printing is the process of making solid objects. We prepare a file and then we make solid objects, or we print solid objects, or we manufacture solid objects. And because of this 3D process, we can print almost anything, any geometric structure or any household article or any object, whatever we want to, we can print using a 3D printer. 3D printing is also called as additive manufacturing. Why it is called additive manufacturing is because we have another manufacturing called subtractive manufacturing. We are familiar with subtractive manufacturing. In subtractive manufacturing, we use material and then cut out the desired shape and size from it. We chip off the extra material in subtractive manufacturing. We use for example, if we want to create an object from wood, we take a block of wood and then chip off the extra parts and carve what object we want. That's subtractive manufacturing. That has its advantages and disadvantages. And then comes additive manufacturing. Here we build objects without wasting much of the material. Here the objects are built in layers, and we keep adding layer after layer to complete the object. That is what is additive manufacturing. That's how the adding layer after layer, that is successive layers, layer on top of layer, and that's how we are completing the 3D. I'll show you a picture. The next slide is it is the model of the Eiffel Tower in the process of being 3D printed. This is how we print a 3D object or 3D model. The printer prints the entire surface in successive layers, line by line. That's how we stack papers on top of each other. That's how we call each layer. That's you can take this example from notebook. We have lots of papers stacked on top of each other. So that's how layers are in 3D printed. And this this model will completely look like exactly as Eiffel Tower. This is how we create 3D objects, and the plus point is there is no limitation to the geometry. You can create any type of geometry you can create, or print any type of structure you want. This is how 3D printing works. Next comes the history of 3D printing. When did it all start? The idea, even before any scientist or inventor thought of it, this idea was conceived by Lithography in 1945 in his science fiction novel Things Pass By. And, there's another mention of the same thing in a 1950 short story. So this is how the conception of 3D printing started in literature, and then it transitioned to the actual model or the actual invention. Next, and then when people started thinking about the feasibility of 3D and the technology that can be used, and the uses which this technology can be put to, there was a wave of research going on in the entire world. There was somebody from Japan called Hideo Kodama. He was a patent lawyer. He wanted to patent this method. He actually invented two methods of additive manufacturing or additive fabricating in 1980. That's how it all started in practice. But then his model was rejected, and the project was done. It was lacking in the scientific world at that point of time, because technology in other areas was growing and people did not pay attention to what Adama was saying. And more or less 3 or 4 years later, Europe, three French inventors filed a patent for a process for 3D printing. But again, the funding agencies abandoned the idea because they didn't want something which did not have a business perspective, something which did not have a good business perspective was not for them. So in 1984, the French inventors were again rejected. Next, while Europe was not paying attention to 3D printing, halfway around the world, in the USA, there was a man called Charles Hull. He, around the same time as the French patent got rejected, Charles Hull invented 3D printing, and in 1986 he got the first patent for it. He invented a stereolithography technique that we'll see in the coming slides, and that's the man who invented the 3D printing thing. Behind him is a 3D printed object which is illuminated. And from there began the journey of 3D printers. In 1992, 3D Systems Corporation made the first ever 3D printer for commercial use. There were many processes which were patented, and there was a lot of research going on simultaneously during 1980s and the 1990s, while the first 3D printer was manufactured, and SLS technique and the SL technique were in their nascent stages, and research was still going on. In other parts of the world, there were parallel researches going on, but then nothing survived. Not many survived. So in 1999, scientists actually printed an artificial organ and they also implanted it in a patient. And that patient was doing well even after 10 years. There was no complaint from the patient, and the patient survived. The patient was doing well. So then there was a lot of possibilities opening up for 3D printing. In 2002, of course, at the turn of the millennium, scientists started getting into more research for this. In 2002, they printed a fully functional kidney, human kidney. And then again, the rest is history. In 2019, scientists printed a rabbit-sized heart, which could actually work like the original. It could pump blood, and the blood vessels would contract like human blood vessels would do. So this paved way for so many possibilities in medicine and in other fields. This is a picture of a 3D heart, and it is almost the size of a human heart, the exact size. So 3D printed heart would function exactly how a normal heart would function. This is the possibility that 3D printing opened up. Next is the RepRap project. In England, there was a team of developers who wanted to print an entire printing machine or a 3D printer. They wanted a low-cost 3D printer and they wanted it to print its own components. They didn't want to manufacture the components in a factory setting. They wanted the printer to print its own parts. What they did is they actually made a 3D printer, a low cost that too, and with from that they printed most of its own components, and they constructed another 3D printer using the components printed on this machine. The RepRap is short for Replicating Rapid Prototyper. Why we are using the word rapid is because this printing can be done rapidly. We don't have to wait for assembly lines. We don't have to wait for the manufacturing process in the factory. We don't have to wait for the processes and machines and people. So this project now has a lot of collaborators all around the world. Here we have two of the people from the team where both the printers are showing, and one is the parent printer, the other is the child printer. The printer on the left, the parent, printed most of the parts that are in the child printer, most of the plastic parts. So the parts printed by the printer on the left, were used to make the printer on the right, and the printer on the right is now a fully functional low cost 3D printer. So what this is a huge leap in the field of 3D printing, where one printer can print its own parts, and maybe we can keep them as spare parts and use them when actually some part goes wrong, or some part goes missing, or some part doesn't work. That is how the machine is replicating itself. So this is the RepRap project. Now comes the turning point. There were three technologies or processes, printing processes patented, and the best and the cheapest was fused deposition modeling, that's FDM. So this FDM printing process patent expired in 2009. And that is how the entire procedure and the entire process fell into the public domain. The thing with patents is we have two types of patents. One is the utility patent, the other is the design patent. Utility patent is something that we can patent, or we can something like a copyright for the actual working of something new that we have created. It means that nobody else can copy our design and nobody else can manufacture it without our consent, just because it provides a way uh, for the manufacturer, for not the manufacturer, the inventor or the owner of the design, benefit of both the intellectual property as well as the benefits in finance or the money coming out of the project. So the patents expired in 2009, and that means once the patent expired, it cannot be renewed. But then when you file a patent, it is mandatory that you disclose the entire process of it. When you disclose the entire process after the patent expires, the entire process falls into the public domain and anybody can manufacture it. The processes for the patent expiry, for the patent license for utility is 20 years, and for design patents is 15 years. When in 2009 these patents expired, there were many manufacturers who wanted to manufacture 3D printers. So they used the fused deposition modeling process in their printers and then started manufacturing. There are a lot of manufacturers worldwide who now manufacture 3D printers, and fused deposition modeling is not only cheap but also easy. That is a desk. It FDM printing machine or FDM 3D printer is the size of maybe an oven, a microwave oven, a little bigger than that, and you can place it on your desktop and then just start your desktop manufacturing. Next, now let us see what the general principles of 3D printing are. 3D printing usually involves three steps. The first is modeling, the next is printing, and the last is finishing the design. First thing is modeling. In modeling, you just have to create or prepare a design file using computer aided design. Now, computer aided design is something in which we use softwares to help create a design, a 2D design or a 3D design on a computer. It's a digital file. It's just a digital file. You can see it on the computer. You can design it whatever way you want. You can have any geometric designs. You can have any object. You can have household objects. You can have spare parts. You can design ceramic. You can design plastic objects. It's like it has endless possibilities. So these are the files that are saved in STL format. That's stereolithography. We'll come to that again. And but STL files have some problem because they are large files. There is a new format added in 2012 that's called a CAD file format, for additive manufacturing file format, AMF, and this stores information using curved triangulations. Curved triangulations is something in which the information is stored using triangles. The entire object or the entire 3D image we construct in the computer using the computer, that entire digital file is saved using triangulations or triangles. There are small triangles which form part of the bigger picture. So when modeling an object, we design it using CAD software. There are number of CAD softwares which are proprietary, and many are free as well. There are CAD software separate for architectural designs. That's for architects. They use that for geometric designs or designing buildings. And then we have separate CAD design software for artists. Then we have separate designs for people who manufacture or people who print medical supplies or medical devices. So there is a software for each use or each different application. The first thing that is modeling, the thing is you'll have to have a computer and then design the file, design the object virtually or on the computer. STL file will only contain the surface geometry. It will not contain the color or the texture or probably the size. You can, after you model this, you can then use a slicer software to print this model. The slicer software processes the STL file, and then we can add color to it. We can actually see how it is going to turn out after the print. And there might be some errors which can be removed using the slicer software. Slicer software, there are again a number of slicer softwares available. It all depends on the user who wants to use what software. Slicer software will divide the digital file into layers. It slices the entire digital file or the entire digital 3D object which we look at in the computer into layers, into lots of slices, slice over slice, slice over slice, and that is how we print the objects. Next is the finishing. After the object is printed, sometimes it needs washing, sometimes it needs removal of extra parts, or sometimes it may need sanding just to make it smooth, or a razor blade or a foam brush, or sometimes we may need to color it as per our requirements. So the finishing part is again dependent on what kind of texture and finishing a customer wants or you want. Some people dip the object in alcohol for a smoother finish. Is there a doubt, sir? Okay. So this is how it works. It just finishes in 3 steps, but then the time it takes is a lot. We think there are just 3 steps, but then in the modeling thing, you just model the object, or sometimes you can only click a picture of it and then directly go for the printing thing, because the slicer software does a lot of work, and then we can finish the product or the object. Next is, why do we need 3D printers? We already have products which are manufactured in factories. We already have everything available. Why do we need another technology where we, the customers or the users, have to print our objects personally? We might not need it, but then there are a lot of advantages, there are a lot of applications, and that is why we require 3D printers, because every day, each day, even as we speak, technology is advancing. Technology is not going backwards, it's going forward. So every day we need to keep pace with it. We need to be up to date with technology, and we need our work to get done easier than what it was yesterday. I would want my work to become easier and more professional, uh, maybe perfect with each passing day. So that's why we are using 3D printers. The first thing is, here there are a lot of points of why we would use 3D printers. I have consolidated them and then picked the best points. The first is, they do not require any mold as a precursor to manufacture. Molds are not dies exactly. Molds are something which in which we can cast the material and then print or manufacture a lot or a number of the same looking objects. So that mold is not required in 3D printers. A 3D printing machine does not require a mold. It just prints. Just like how we print from a 2D printer, we print on a white paper. And do we require a mold? We do not. We just insert a paper, there is ink, and that ink is a liquid form, or we have laser printers. So what happens is, we don't need a mold. We can print whatever we want. We can print something that never existed before, or our printer never printed before. We can print in any language. There is no restriction on the language we print. There is no restriction on the images we print. There is no restriction on the type of paper we print. There is no restriction at all. Whatever you see on the screen of the computer, you can print it. Exactly. That's exactly the case with 3D printers. They do not require any mold as a precursor to manufacture. In manufacturing units or the factories, they would require a mold. Not here, not necessary. We can print n number of objects. We can print any object we want. We can print any number of objects we want. We can print any color we want, the color of the objects. There is a lot of possibilities here. The first thing is, they do not require any mold. The next is, they are economical to own. When the 3D printing business started, one printer cost around $3 lakh. $3 lakh. That would be a lot in Indian money. But then now we have hobby level printers, which we can buy for maybe 20,000 or 25,000. Of course, they are just entry level printers, and they will need a lot of perfection to be dealt with. But then we can own a printer. So they have now become economical to own. Previously, when the 3D printing business started, only top companies used to have these printers. Now we have commercial 3D printers and commercial 3D and yeah, office level 3D printers, which can be used in offices, homes, and labs, and which are definitely affordable. And then the next thing, why we use 3D printers is because there is no limitation on the geometric complexity. You can print any geometrical design, any mathematical design, any intricate design, any logo, any architectural model, anything. You just can print about anything. And there are people in Europe and the US who have printed entire houses with a 3D printer. They have printed an entire house. They have prepared cement. They have fed cement to the printer, and the printer entirely printed the house in which they can actually live. So there is actually no limitation for this 3D printer. It can print about anything you want, of any size you want, of any material you want. And then we have the hobbies level printers too. Why we need 3D printers is because it's fun. It will definitely hold a sentimental value when you print something of your own. When you print something what you like, when you have some, you are part of the manufacturing process, when you are part of the printing process. That's why we maybe like 3D printers. And then there are a lot of objects which can be made. We don't have to go to the shop looking for these things like jewelry, crafts, fittings, maybe. And then there is another thing why 3D printers are beneficial. That is, sometimes there are spare parts which we need to order from the company, and by the time the spare part arrives, the entire work slows down for want of just one spare part. And that spare part could be actually manufactured on our desktops just using a 3D printer. So that is the reason why we need 3D printers, why 3D printers have become an integral part of the technological world. So these are the reasons why we need 3D printer. And next, on the next slide, we have a time lapse video of a 3D printed monument. Everybody, all of us know what Taj Mahal is. So let me play this video. It's about a minute long. So So, dear participants, that was how this piece of marble was created, and it looks exactly like the original Taj. So, this is how you can create a lot of things in a lot of sizes. There's another video on the next slide, but then we'll get back to that later. Now let us see how many types of additive manufacturing we have. We have 4 types of manufacturing. That's SLS, FDM, SLA, and DLP. And in the next slides, we'll see what these are. The first is the selective laser sintering. And this is a technique which uses powdered material, dust. It uses dust of the material, and it instead of um, instead of melting the dust and forming an entire liquid, this process uses pressure or heat to bind the dust or the powder so that it becomes a sheet or it becomes an entire layer. So this is called as selective laser sintering, and we use laser here. The printer, you can see the printer is, it must be 5 or 6 feet in height, and that's how big it is. So this is a model of the SLS printer which uses laser as the source of heat, and then it binds the material or the powder which is given into it, and then it creates a solid structure. This is an expensive process. So this still exists. It is expensive, but then there are a lot of companies which use this type of procedure to make their models. Next is FDM, that's fused deposition modeling. This is a printer which hobbies use. This is an affordable printer, economic to own, and does not occupy a lot of space, and very easy to use. FDM is also called as fused filament fabrication because the filament which we use here is fused. It is melted, and then it solidifies upon printing. So it uses a plastic material for a filament, and that is fed a spool of the entire plastic is fed. And the filament starts printing. The moment it prints, it solidifies upon contact in it. So that is how FDM modeling is done, or FDM printing is done. Next is the stereolithography process. That is, here we have a photosensitive liquid um, that is solidified on contact with light. So this is another 3D printing process, which is again expensive, and there are a lot of companies which use this for prototypes, industrial prototypes. Next, we have the digital light processing DLP printers. It is an extension of the SLA process, and instead of using lasers, it uses the light from a projector to process the material here. So these are the 4 types of processes people use in 3D printing. Next, we have what materials are we using in 3D printing. We have a lot of materials which are currently in use in 3D printing. That's plastic, powders, resins, metal, and then carbon fiber, graphene, graphite, nitinol. There are more material coming into um, the purview of 3D printing each day, because research is still going on in 3D printing, and more materials are being used for 3D printing for the flexibility and the texture and the geometry and the density of the material to be object to be made. We'll see the first thing is plastic. That is, of all the raw materials that 3D printing uses, plastic is the most common. Plastic should be the commonmost material for 3D printing, because plastic has entered our life as in so many ways that we cannot just remove it from this. So products made from this technique will include a lot of household fixtures, toys, maybe utensils, and some biodegradable uh, products. And the thing is, one of the variants of plastic is PLA, which is also eco-friendly and which is sourced from natural products. So this is also firm, flexible, and plastic has an advantage of offering a lot of colors, bright colors that too. And again, then it's affordable. It is actually economical to use plastic, easy to use it, quick, and then a nice option for 3D printing. This is the picture of a 3D printed object. I think you've seen it on the previous slides. That's the first or second slide. So this is an object which I got 3D printed yesterday evening. Allow me to switch on my camera so that I can show you the actual product. I hope you can see me.
Yes, ma'am.
Yeah. See this.
Yes, ma'am.
Can you see this? This is a small 3D object I got printed yesterday evening. It must be like 2.5 inch in length. It's a small hello.
Yes, ma'am.
Yeah. So there was the black filament available and the green filament. I chose green, so we didn't have any other colors. Anyhow, I got it printed, and then there's more. See, I got 3 objects printed. See, this is the thing, but then I took a picture. This combines 2 different words on the same model. Can you see this?
Yes, ma'am. Yes, yes.
Yeah. See this, and the material used is plastic. It's lightweight and it's sturdy. And next I got something printed. Yeah, the 3D printing thing depends on how thick you want your object to be, or um, how polished you want your object to be, or what color or texture you want your object to be. I got a strip of coins printed from 0 to 100. Ma'am, I think one of your mics is open. The mic is on. Yeah, thank you so much. See, this is a coin. I got print a set of coins. Plastic. It will look exactly like a plastic toy because I wanted it to be thin. And um, what I'm trying to show you here is these 3D printed objects do not have a lot of waste material. Once I remove this, I'll be left only with this part, the frame part, which is the only waste material I am not manufacturing, which is the only waste part I have, and then I can throw this away. The best thing about 3D printing is you don't have to waste a lot of material. The same thing if you go for subtractive printing, you will have to chip off the entire plastic thing and then carve the useful thing or carve the object from it. So this is the thing I got printed, and I'll switch off my camera so that we can concentrate on the PPT. It took me a total of 5 hours to print these three things, because 3D printing is a slow process. It is not fast. It's not like how you print paper. So this took me 5 hours entirely, and I think I have a video capture of this. We'll have the video maybe in the coming slides. Till then, we'll see what more materials we can use for 3D printing. The first thing was plastic. I used plastic for my 3D objects or the models. And next come the powders. Powders are materials that are common again. We have nylon powders, and then we have alumite. Nylon is a very strong material, and it is also flexible. There are 100 things which we can make from nylon. Nylon is flexible. Nylon, it has a lot of tensile strength, and that is why it is also used in making fiber or clothes. And nylon, for that same reason, we use nylon in 3D printing as well. It is used to print fasteners or handles or toy cars or toy figures or action figures or cartoon figures. So this is how we take nylon, and then we manufacture it into a powder and then feed it to the printer. Then we have the 3D printing from nylon, using nylon. The same goes with alumite. That alumite is powder again. It's a mix of polyamide and gray aluminium. And aluminium is a strong metal. It's a material. It's very strong. And the same thing, it's strong. It's grainy and it has the sandy appearance. That's the reason why it's used for industrial models and prototypes. Here we have an object printed in nylon. This is an object which we can actually use for use in, I think this is a spare part which can be used in industry. So the next material we use is resin. Resin is a liquid. It has very limited flexibility, very limited strength, and that's the reason why this is less commonly used in printing. When we 3D print an object, all we want is to last for long. We wouldn't want it to just break, or we didn't want it to not be flexible. And that's the reason why resin is the least used material in 3D printing. But there are some people and there are some applications which will require resin to 3D print the objects, and that is where resins come in. And generally resins are black, white or transparent, but then you can still add color for them. They are used for making small household accessories, maybe taps or handles or some fixtures or chess pieces and rings. We make objects from resins which do not require a lot of bending. So that is one thing. Next, I think we have 3D printed objects in resin. These are the objects which have been 3D printed in resin. Generally they are transparent in color, and sometimes we have chess pieces. Chess will require only white and black or transparent and black, and that's where resin comes in. The next thing is metal. Metals are the second most popular after plastic in 3D printing. So in while using metals, we sinter them directly by using a metal laser, and then the powder is used in the printer and the final object is printed. And the metal can be gold, it can be bronze, it can be nickel or aluminium or stainless steel or titanium. These are the common metals used. There are still other metals which are less commonly used, but then there are a few objects that have been printed with metals other than described here. So some medical devices have also been printed using metal. There are medical devices which use metal, and they have also been printed, and they have also been successfully used in patients. We have here a 3D printed gold ring. The image on the left is a gold ring with all the it's in the raw stage. It's still needed to have stones set in it. That was 3D printed ring, and a person from Europe or the USA commissioned it for 3D printing. And next, in the image on the right, we have the finished gold ring, and the stones are already set. So this is how they 3D print. Now, when you look at the texture or the fineness of the ring, you can find that uh, made with hand and objects 3D printed have a difference in their entire uh, finished quality or the entire look that you have. So this ring is not only costly, but it also has sentimental value. Why 3D printing and metals, especially gold ornaments and jewelry, is not very popular here is because since we have to use powder for metal printing, we generally skip the thing because powdered gold is very expensive, and that will make the ornament or jewelry extremely expensive. So people generally go for things that are not expensive. We pay for the gold. We do not want something that is highly expensive where we are getting the same amount of gold. And uh, you can note that the gold that we use here is not actually 20 karat gold or 21 karat gold. It's usually 18 karat gold. Again, that's the reason why it is not also popular in India, because here we prefer a higher carat gold. We do not go for 18 carat gold. So that's a very good gold ring. That is a website from UK. And the next, we have a 3D object printed in aluminium. Aluminium is again used as a powder, one of the metals, and that's a 3D object printed in aluminium. So we can go to the next material used in printing, that's graphene and graphite. This is a popular choice for 3D printing because it has got a lot of strength and again conductivity. It it is used for manufacturing or printing parts that are flexible. Because previously we saw one material which was not flexible at all, but then this material, graphene and graphite, they are very flexible, and it is also used for solar panels and used for objects which need bending or which need a lot of flexibility like touch screens. Also, these are used for building parts, that is in architecture. And some people believe that graphene is the strongest material used in 3D printing. Here we have the 3D printed impeller that's used in machines. And next we have nitinol. This material is used in the medical world. This material is a mixture of titanium and nickel, and it is corrosion free. It does not get eroded, does not get corroded, and that's the reason why we use this for printing medical implants, which can be implanted in the body. In the next slide, we have stents which can be placed in arteries if they are blocked. These are 3D printed and made in nitinol. So these are the arterial stents which can be implanted in a patient, and because of the quality of the material used, they do not get corroded. And the advantage they have is, since they are 3D printed, they are printed to the exact size and dimensions as required by the patient, because this will require precision, and size is a big concern. So 3D printing helps us to scale down or scale up or print exact model or the exact specifications of the requirements. Next, we have the carbon fiber. Carbon fiber is used as a top coat over plastic materials, sometimes over graphite also. The purpose is to make the material stronger, the purpose is to make the object stronger. And um, since all these materials are being tested and are being researched, we can hope that we will still get the best of all these materials, and we hope the best of the materials survive and it reaches the common public. Here we have an object printed in carbon fiber, and yeah, the next slide. Where can we use 3D printing? We now know what 3D printing is. We now know what processor it uses. We now know what materials it uses. Where can we actually use 3D printing? There are medical procedures which we can use. There's advanced manufacturing. There's prototyping. Product prototyping is a big part where 3D printing can be used. There are many designs which have to be tested before they are rolled out. For example, there was this example in a previous lecture of the digital twin, where the Mercedes car company had to recall 2,500 cars due to a manufacturing defect. But then what if we could actually have a prototype of the car or the machine and then test it, remove all the defects which it has, and then roll out the actual car or roll out the machine without any defects? So that is where 3D printing comes in. Next is historic preservation. Historic preservation is where see, let's take an example. India was a colony of the British for maybe 200 years, but then there are a lot of British artifacts in India, and there are a lot of Indian artifacts in Britain. Most of the time, the origin country wants to have those things back. So both the countries contending for the same thing, that creates problems. But then when there is 3D printing in existence, we can print the artifact, we can keep a copy, or we can keep the original and give the copy to the country who's asking for it. So this is how we can preserve history. We can make copies of the same thing and then preserve history of both the countries. Next, we have automotive industry. That's the example I told about the cars, machinery. And then we have architectural engineering, we may create prototypes, or we may create 3D models of a building, test them, or we may see if we can actually have a practical model of an architecture we want to construct. So this is where 3D printing comes in. Before we make the actual product, we can have a prototype, or we can have a model, and we can 3D print for medical procedures. We can go for advanced manufacturing. We can go for immediate, rapid manufacturing. I want a part in my machine which is missing, and I cannot go running to the market, or there is shortage of that part. I can print it on my own. I can print it to whatever dimension I want. I can print it in whatever color I want. I can use the material I want, and I can have it printed immediately. That's the fun in using 3D printing. Next is, oh yeah, this is the video I captured of printing the hello thing I just showed you a while back. And this is a time-lapse video. It took about 30 minutes. 30 minutes to type this small piece, and I have trimmed it down to 13-second time-lapse video. I hope you enjoy watching it. This was the video of the hello object I captured, and that's the printer. That's the FDM printer we used for printing this object. We have another video, and here that there's this thing about the video. It's not a time-lapse thing. I captured it for a few seconds, maybe half a minute. I want you to listen to the sound the printer makes while printing this machine. Yeah, let me play it. There are a few things when we start 3D printing. That's just because we are providing a plastic filament, and it has to be heated. It This has to be a temperature controlled environment, and the machine which you see here, the Ultimaker machine, mm, it is a commercial grade machine, and it costs maybe 5 lakh rupees or something, because that's commercial grade. For hobby grade machines, you can go for something that's 20,000 or 25,000, but then again, there would not be as many features as you find in a commercial grade machine. So here, the first part of the session is over, where we have seen what actually 3D printing is, how it works, where you can use it, what materials you're using, and then why we want to use 3D printing. Now, since we are using augmented reality, virtual reality, and mixed reality, and a lot of other realities, how can those realities help in 3D printing? How can those things actually aid in 3D printing? What is the role of augmented reality and virtual reality in helping advance 3D printing? We have seen this. Now, if I say that I have a digital file on the computer, and I want a 3D printed object of that file, fine, I'll get it. But then I would not know if there are any errors in it. I would not know if there are any geometric deviations in it, or if something needs to be scaled down, or or how actually the object would look like after it is 3D printed. All I can do is I can imagine. I cannot see it. There, that is the thing, that is the time, that is the place where augmented reality and virtual reality come in to help take 3D printing to the next level. Now let us we already know this. We have a fair idea of what all these realities are. See, for virtual reality, we have a headset that will completely take over our vision and take us into a different dimension, take us into a different realm, making us believe that we are somewhere else. We are not standing here, but we are somewhere else. Maybe in a galaxy, maybe walking on the moon, maybe in Disney World. There are so many possibilities, and there are a lot of headsets which are available in the market, and those headsets completely block our vision. When we wear them, we cannot see anything. So when we put them on and they turned off, we think that we are blindfolded. We can see nothing. We can see nothing of the outside world. That's what is virtual reality. And when we turn the headsets on, there are panels inside, and we see a field of vision. Generally, this field of vision spans only a few couple of meters around us. Whatever is being displayed, we can see in the field of our vision. Most of the time, it's used in games or videos or virtual walkthroughs, maybe. And the best part is we can go anywhere we want, and the entire surroundings, our entire world is replaced with a virtual world. So all these virtual procedures are used for both games and apps, and we can go places, and where we are standing or where we are sitting, where you are physically located, does not matter. So that's what is virtual reality. That's a completely immersive technology. Next, we have the augmented reality. That is, we are augmenting, or we are just adding something to our natural environment. We are adding something to the physical world that is actually visible to us. We definitely will need a device here, a mobile phone, maybe an app or a camera or a lens or headgear or glasses. But then this will differ from virtual reality in the sense that your vision is not completely blocked. You will not feel as if you are blindfolded. You will see something overlapping in the physical world which comes from a digital world. So the smart glasses are transparent, and they let us see everything that's around us, plus something that we have augmented on the physical world. So this is designed for free movement. Let me add, the virtual reality technology is not designed for free movement. You have only a space of a few meters around you. Otherwise, you can trip over cables which are connected to the computer. We do not have a technology so advanced where we can have free movement in virtual reality. So in augmented reality, we have free movement, and we are projecting images on the physical world. We are projecting images on our surroundings using a pair of glasses or a phone or an app. So this is what is augmented reality. We are overlaying data, and we can have something as complicated as holograms floating in the middle of the room. We can have something as a sofa we just saw here. This sofa, the blue sofa, is not actually present in the room. It is only an overlay which we can see on the phone, just to see how it would look when we place it here in the room. So that is what is augmented reality. Here, I have a small example of Flipkart's 3D shopping feature. If any of you are using a laptops for this presentation, you can scan this code from your mobile phone and then uh, have an experience of it right here. Flipkart started this 3D shopping feature maybe less than a month ago, and they have rolled out two furniture items for this. One is a sofa, no, one is a table, and the other must be a refrigerator. And for those who are using the mobile phone, you can directly use these two links, which can take you to your Flipkart page, and then you can have a 3D experience where augmented reality is at work. You can watch the table or the refrigerator as how it would seem your surroundings or how it would look in your own room. I'll share the PPT at the end of this session. You can definitely have this experience. So this is the first 3D feature in furniture offered in India. I am sure definitely after this, a lot of other websites are going to follow the same. We have Amazon, why Amazon be behind? We have many other shopping sites where we use. And it's not just about Flipkart using this feature for their furniture thing. We already had this feature in Lenskart, I believe, for trying on glasses or sunglasses or frames. And we have features in Snapchat and Instagram. That's mixed reality, of course. So we have been using all these features for quite some time. And this Flipkart shopping feature is a new thing. We also have this feature in Google. When you just go to Google, type goat, you will have a 3D model of the goat, which on your phone can look like it's walking in your room. Or type the name of an animal like lion or tiger or duck. You can have this 3D feature, augmented reality, when you can use your phone to see this augmented reality. You will not need any extra app or any extra installation for experiencing this. Your camera is enough for this. The three augmented reality thing will use your device camera and then overlay digital files on your surroundings. Next, we have the mixed reality thing. What actually is mixed reality? It's a blend of both the digital and virtual worlds. We now know that augmented reality is a mix. It's a virtual world overlaid on the real world. And then virtual reality is completely virtual. There is no real world involved in it. Mixed reality will involve both the digital and the virtual worlds. And here, the best part is we can modify or we can manipulate or we can interact with both physical and virtual environments. In the virtual reality thing, we are interacting only with the virtual items or the virtual environment. In augmented reality, we can interact with the physical world, but we cannot interact with the virtual items. Mixed reality is something in between, or a mix of both, which takes use of the advantage of both the realities and gives us a choice to interact with both physical and virtual items which we are using. So it generally uses a lot of sensors and imaging technologies, and it allows us to immerse ourselves in the world and keeping us in the physical world and making us interact with the virtual and the physical world is the benefit of mixed reality. We can do all this without removing the headset. Definitely, we will need a headset or a device for mixed reality, and without removing the headset, we can do all of these things. We can interact with both the physical and the virtual world. Next, Microsoft released this image showing the interactions between computers, humans, and environment. So if we go for a Venn diagram or an overlap diagram, here we have the human in the pink. Next, we have computers in the blue circle. Next, we have environment in the purple circle. So how when humans and the environment interact, that's conventional reality. That's the reality which we have been experiencing for thousands and thousands of years. That's what is conventional reality, and that is what we have known for our entire lives. And then came the computer, where the humans and the computer interacted and gave rise to realities which now becomes mixed reality. When we have computer, the human beings, and the environment, three things combined or three factors combined will give you mixed reality when they overlap. So this is how we have the environment around us. We interact with the environment. We have computers We interact with the computers. Using the computer, we can interact with our environment as well. And then the major factor is human beings. Human beings interacting with both the environment and the computer. That's what is called as mixed reality. Next, there are two very different groups of technologies. That's 3D printing and then virtual reality and augmented reality. Should we combine these two realities? Should we integrate them? They are already doing fine separately. Why should we do it? Why should we integrate them? Is there a need? Are there scopes? How is it going to happen? And are we not having enough technology already? So why keep combining technologies? How will it benefit us? The answer is why not? Why not we combine technologies for a better experience? Why not we go for technologies that give us an easier way of life? Why not we go for technologies and combine them where we can save lives, where we can save people, where we can save the environment, where we can be eco-friendly, where we can save time, where we can be economical, and we can still be technologically advanced. So why not we combine these two different groups of technologies? And next we'll see what happens when we combine these two groups of technologies. Here we have again an image from Microsoft. To the left, we have the physical world that's been existing for millions of years, and then to the extreme right, we have the digital world. It just exists in imagination. This digital world exists only in people's imagination. There is no physical existence to it. And how do we reach the digital world from the physical world? We reach it using augmented reality, virtual reality, and mixed reality. I'm sorry for the dark image. This is the best I could download from Microsoft. And there's this augmented reality thing. Here we have the headset, then here we have the mixed reality. This is a smartphone. And then here we have the virtual reality, again the headset. To reach the digital world from the physical world, we will need devices. We need softwares, we'll need apps, we'll need devices, and we will need getting used to these things. So this is the mixed reality spectrum where the distance between the digital world and the physical world has shrunk. This is the mixed reality spectrum where sitting in the physical world, you can reach the digital world. You can work, you can manufacture, you can go on saving lives, all sitting in the physical world where after you remove the headset or minus the app or minus the software, the digital world does not exist. But the digital world can do a lot more, can save lives, it can create money, it can create business, it can create connections, and it has a lot of scope for technology as well. So this is how you connect to the digital world sitting right in the physical world. Going to the next slide. Yeah, we had a question. Why do we need to integrate these two technologies? Why can't we just stay with whatever we have? Why can't we be thankful to whatever we have and for whatever we have, and then just go with the flow? We have an answer from a doctor from University of California, San Francisco, who says that for him, 3D technology have helped in surgeries. He used 3D printing and augmented reality to help bridge the gap between the 2D world of radiology and the 3D real world of surgery. What he's trying to say is, okay, let me give you an example. Most of you have used printers, 2D printers for printing paper, for printing documents, or maybe a Xerox machine, office copier. So when you have a manual for these machines and you encounter a problem in the working, you just refer to the manual. There, there are a lot of instructions written. For some particular issue, you have a solution. But then when you look into the manual, it's all 2D. You are working in the real world and you have to translate whatever is written from 2D to the actual world. You have to translate your imagination, what you read in the manual about fixing this machine, to the actual 3D thing. So this takes a lot of time. So you have to translate something which exists in your mind to something that exists in the real world. I have faced a lot of problem in a lot of situations this way using manuals. So written manuals are one thing, and getting into the field is another. So this doctor says that 3D printing and augmented reality both have helped him bridge the gap between radiology and surgery. Radiology is something where there are images on printed sheets like X-ray or maybe CD scans or something like that, some scans. So when they see the scan on the sheets, that's a 2D scan. You cannot see 3D images or you cannot see three-dimensional organs in that. So when he sees something on a 2D image, he has to translate that into a 3D thing when he's actually doing surgery. So that takes a lot of skill, takes a lot of confidence, and that takes a lot of faith in oneself. Just to bridge that gap, we have 3D printing with AR that can help us in here, in his case, in saving lives. That's what he says. Next is, how can we say that these realities or these technologies complement 3D printing? They allow for rapid prototyping and iterative model improvement. We can always keep improving our models in the next prints because we don't have a mold. We just don't have to print the same thing again. If we find fault, we can keep improving it. And again, we have seen it, it's economical and environment friendly, and you can repeatedly test on the augmented reality feature because you're losing nothing. Augmented reality is just a digital file that exists in your computer. You can repeatedly test it, there's nothing to lose. And then we can overcome constraints of physical models. If for surgery, for example, the same doctor at the University of California wants to perform a demo surgery, he can prepare models, physical models out of maybe plaster of Paris or maybe silicon or maybe many other materials. So when he performs surgery on physical models to be confident for the actual surgery, the once performed on a model, that model will definitely be not useful for the next time. So here, when you have augmented reality, you will overcome the constraint of physical models. You can use the digital model that's inside your computer n number of times. So that's the beauty of both of these technologies merging. Next, we can have remote collaboration. There's somebody sitting somewhere in Europe and there's somebody sitting somewhere in India. Both of them can collaborate using augmented reality. Maybe I can use the same example as the office copier Xerox machine. I may collaborate with somebody who's sitting far away, millions of thousands of miles away, and then ask him and then show him. He can show me a model overlaying the actual parts in a digital file over my copier machine, and then I can do it. I can fix it myself, and that's the thing. Next is customization. Here, for every separate application, for every customer, there are different needs. Surgery cannot be the same for each patient. Each patient's needs are different, and it's not just limited to the medical world. I may have a different requirement when it comes to my 3D objects, whichever I am printing. The object which I just printed, like hello, I may have a requirement of green. Somebody else may want this same thing in a blue thing, in a blue color. Somebody else may want something else. So customization is a big thing that I can make use of using AR, VR, and 3D printing. And then we have reducing waste. Just like how I mentioned earlier, in subtractive manufacturing, we have a lot of waste. We have a lot of waste material. Here, we are not wasting anything. We are only using the material that is required for printing our object, and That is how we are reducing the waste. So this is how augmented reality and virtual reality can complement 3D printing if we use augmented reality before or during 3D printing. So to show you an example, let's go to one of the previous slides which we skipped, where we had a video of a robotic arm. Here, printing something. The robotic arm is printing a teapot, and they are using augmented reality for it. Let me play the video. This might be a bit long, maybe 3 minutes. And if you find it too long, we'll stop in the mid, and you can always have it when I share the PPTs with you. But then for the time being, let us at least watch for a few minutes, few seconds at least. Dear participants, I hope you can see the video. Is the video visible?
Yes, ma'am.
No, it's not visible.
No, it is visible. Now it is.
Visible, ma'am.
Okay, if you pin this video, or you pin, my name is Ismat here, they're visible on the
It's
screen.
visible.
Yeah, that would be fine. Here, I just wanted to
Visible,
mention
ma'am.
something. See, there might be some errors creeping into this object while it is being 3D printed. So you can visualize the entire final product as to how it would look after it gets 3D printed. So that's where the augmented reality thing comes in, where you can correct any defects or errors during the manufacture or during the printing. So let's continue with the video. Dear participants, let's skip to the end of the video where we can see the finished product. Yeah. This is the finished product that was made using the robotic arm and augmented reality, where the printer, that is the human being who printed the teapot, corrected for any errors. So basically here using augmented reality means translating your imagination and seeing it outside of your mind. That is where augmented reality comes in. That is what is augmented reality. You are actually seeing what you see in your mind with your eyes. It no longer remains an imagination. You can see it, you can actually create things with it. That's how augmented reality and 3D printing complement each other. Let's go back to the slide where we left. This was it. How we complement both 3D and AR. Both of these technologies complement each other. Of course, both of these are standalone technologies, but when we combine them, we have a better technology. Next is, this is how we can have AR visualization with 3D printing. There is this patient who's got a tumor in his bone. That's the green thing which you can see, and that tumor, you cannot open up the patient and then keep experimenting on him. So they have taken imaging, CT scans maybe, or some X-rays, and they have created 3D models on the app they are using. And now to see the tumor or to see the picture from all angles, they have created 3D markers. So these 3D markers help them see the pictures from each angle of a surgeon's perspective. In the left side of the image, we can see a 3D marker in one hand, and then the person holding a mobile phone in one hand, and then this position of the 3D marker will show the bone in this way, this overlay. And then on the right we have another picture where the 3D marker is kept in some other position, and we are able to see another view of the same bone, so that the surgeon can finally decide how to perform surgery on the patient and what exact techniques, what exact tools to use, because every patient, like I told you, every patient is different and needs precision surgery. So to avoid mistakes and to save lives, that's all it's doing. That science and technology have basically been doing this since they were brought into the picture, into the larger picture. Most of the time, surgeons, more than engineers, surgeons and healthcare experts are using these technologies on their patients to have better, to provide them better care, provide them with better results. Next we have, where can actually we use? Can we use it in places other than healthcare? Can we use it in places other than manufacturing? Yes, why not? We can use 3D printing and augmented reality, virtual reality in teaching and learning. We have STEM courses, that's science, technology, engineering, and medicine courses, where we can teach students, just like how we teach students. There was this slide, just like how the surgeons can have a full view of the tumor, of how to perform the surgery, in what direction the tumor is moving, how they are going to use their instruments. That's how we are using in healthcare. That's how we are using in medicine. The same goes with engineering students as well, engineering learning and teaching as well, where people or students can have a look into machines. We need not go to the actual factory, or we need not go to the lab, where we can sit at our desk and then have a view of this. We can 3D print models using AR and VR, and we can 3D print models of human parts. We can 3D print models of human organs. Then we have surgical planning, we have imaging. Then there is aviation industry. Aviation industry needs precision. You cannot deviate from the design. So there is a lot of scope in aviation industry as well. We can use 3D printing we can actually 3D print an entire aircraft. But for that, we need a lot of technology beforehand. We need to see how it is going to come out. It just cannot stay in the imagination. It cannot just reside in our mind, and we cannot translate it on a 3D printed thing. We cannot correct errors after the aircraft has been manufactured using a 3D printer. For that, we'll first need to visualize how the aircraft would look like during and before the manufacturing. So that is where aviation industry the 3D printing and AR integration comes in. And then we have astrophysics, we have geophysics. These two fields are where scientists have to discover a lot. The galaxies, the moon, the stars, the sun, there's a lot to explore. So we can actually see a lot of these things using virtual reality. We can research in astrophysics and geophysics, combining both of these technologies. Then we have manufacturing and design. That it includes jewelry, that includes maybe mobile phone cases, that includes plastic bottles, that includes gold jewelry. That's there. And then we have museums. There's this thing. In one of the slides, we saw about historical preservation, and then we have museums here. Here, the thing is, there are people who cannot travel, so we can use AR and 3D printing for printing the models, or AR for museums, and we can take virtual tours. We can reconstruct a lot of the past things, historical things. We can reconstruct events, we can reconstruct artifacts, we can reconstruct a lot of objects which are not actually available today. We can reconstruct the past, we can actually have a peep in history. So that is where we can use integrated augmented reality, virtual reality, and 3D printing. Here I have a video again where a person created a tortoise. He 3D printed a tortoise and a rabbit from complete virtual reality. He uses a headset, and it's a long video. It's about 8 minutes, but then you can always watch it. I'll put it in the slides when I share it with you. Let us see if it works. Yeah. Oh, I have turned off the audio, but then later on you can definitely listen to it. He owns a tortoise, a pet tortoise, so he 3D printed the tortoise, and as a companion, he also 3D printed a rabbit for it. And let me show you. Let me skip parts of this video and show you where he actually uses the virtual reality headset to print that. He is making a 3D model virtually using his headset. This is where he's creating the rabbit.
Excuse me, madam. Madam, screen is not visible, madam.
Give me a moment, ma'am. Ma'am, is it okay now? Because I am presenting my screen. Is it not visible to everybody? Can I have a response, please?
No, madam. Screen is not visible.
No, madam, not it.
Okay, I'll stop the
Not
video.
visible, madam.
Okay, can you see my screen here? Can you see it now? Is it okay now, sir?
Yes, it is visible. Yes, those who are not able to see the video, they have to pin the windows of Ismat ma'am. Okay, so you can have the video.
When you hold your finger on the screen, you will see a small pin beside the mute button. So there you'll have to pin this. Then you can see the screen. Anyway, ma'am, no problem. It's just a video. I'll definitely share my slides with you so that you can look at it again. And we are almost towards the end of the presentation. Next. Here, let's go to the next slide. Before we had any of these technologies, before we had communication technologies or printing technologies, we can imagine that we talk to somebody and we could watch people from distance. We could have television, we could have radios, we could have mobile phones, smartphones, and then we could multitask on the mobile phones, and someday we could have a program with 200 participants, everybody sitting in one place, and then we could have presentations. We didn't have an idea about this. But then since technology is improving and progressing each day, who knows, we may have a lot of improvement integrating augmented reality and virtual reality and then 3D printing. Here is a small meme which I used to show the fact that the mobile phone in the present day goes to a museum and sees the ancestor and sees the old telephone line which we used for communication, and now he says to the child that that's right, our ancestors had tails. So this was not possible a few years back. Talking over the telephone over hundreds of miles was not possible. We couldn't conceive the notion. We couldn't actually sink in that. We couldn't imagine. But then what we are experiencing now is far greater than we could have imagined maybe 10 years back. So the technology of 3D printing is still progressing. Technology of augmented reality is the still reality. There is a lot of research to be done yet in augmented reality, virtual reality, and realities. So this will definitely become an integral part of our lives, and we cannot avoid them. We will have to use them to interact with the outer world, and then we'll have to use them without us even knowing that we use these technologies. So this is how technology gets integrated into our lives, and we get used to technology. We have ease of access, we have ease of procedures, we have time saved due to technology, and then we have the feeling that yeah, we are using technology, and that makes us empowered, that makes us feel empowered. So that is what technology is all about. So when we see that we have augmented reality and virtual reality on the one hand, 3D printing on the other hand, we can combine any type of technology with any other type of technology to have better results, as long as they are not harming us, as long as we don't have a lot of downsides to it. When we talk about downsides, 3D printing has its own downsides. Augmented reality is having its own downsides. And then when we are talking about technology, we are always talking about there are a lot of disadvantages, there are some limitations to it, but then since it is technology and since we are all using it, since it is so integrated in the daily life of an average human being, we cannot refuse to use it. So when we see the integration or the combination of AR and 3D printing, we have a long way to go. We have a long way to go to see where this technology takes us and how it molds in the near future. Hopefully, we have a better prospect of this technology integrating into more technology so that we can have better products, we can have a better life as well. And coming to the end of the presentation, we have Sundar Pichai, CEO of the Alphabet Inc. Of course, Alphabet handles Google as well. So the CEO says, looking to the future, the next big step will be for the very concept of the device to fade away. What he means to say is we may no longer have to use devices to communicate with each other, or probably we may no longer have to use mobile phones or smartphones or screens to immerse ourselves into technology. There might be everyday objects which can become technology. That's what he says, and that's what engineers believe in. That's what we as the new generation believes in, because we are tech savvy people, and we know how we've come a long way from the tailed ancestors of today's smartphones to smartphones, mobile phones, and laptops and palm tops. And so we hope that this technology takes us to better places in the near future. And with that, I will end my presentation. And if there are questions, we can have a question and answer session, sir. I believe the attendance link was not shared because I was busy with the presentation. I'll send you the attendance link shortly on the WhatsApp group. And well, if we don't have any questions, I would like to wind up the session, and I would like to thank you all for attending this, for opting for this program actually, and looking forward to see you tomorrow morning for the next session. Thank you, everybody.